This lecture covers alkene nomenclature and stability. Alkenes are the third functional group that we're studying, and as far as IUPAC nomenclature priority goes, alkenes have higher priorities than alkyl halides, which have higher priority than alkanes. So when you see a compound that contains alkenes, the parent chain is going to be the longest continuous carbon chain with the most double bonds. You want to number it to give the lowest possible number to the first double bond encountered, and you will always indicate the position of the double bond in the name of the compound. You'll indicate all other substituents with position numbers, and since there's an alkene present in the compound, the suffix is going to change from "ane" to "ene." If you have more than one double bond, it becomes diene, triene, and so on. If there's a possibility for cis-trans isomers, we use the EZ nomenclature. The EZ nomenclature is similar to the RS nomenclature, except this is for alkenes. We will assign priority to each group attached to each double bond carbon, and we compare the positions of the highest priority groups on each double bond carbon. If they're both on the same side, it's a Z alkene. If they're on opposite sides, it's the E alkene. There are some common group names to remember for alkenes, and we've already encountered two of them before. The vinyl group is this group here. The allyl group is one carbon longer, and it's this group here. Similar to that, there is the methylene, which is the CH2 of a double bond. So methylene is this group here. And an isopropenyl group is this group here. If we try to name this compound, the first thing we're looking for is the longest continuous carbon chain with the maximum number of double bonds. And so our options are this carbon chain here, it has 2 double bonds and 6 carbons. This carbon chain here, which has 2 double bonds but only 5 carbons. And so we choose the longest carbon chain. We want to give the first double bond encountered the lowest number possible. And so we're going to start numbering from here. So 1, 2, 3, 4, 5, and 6. We also have to name our substituents, and so we have a 5-methyl group here, and we have a 4-vinyl group. Putting it all together, don't forget to alphabetize. We're going to start with 5-methyl, and then follow it with the vinyl group, which is at the 4 position, so 4-vinyl. And then we're going to give the positions of the double bond. We have a double bond at position 1 and a double bond at position 4. And so we're going to name it 1, 4. And we have 6 carbons in the chain, so the root name was hexane. And we'll start with hexa. We have 2 double bonds, and so it's going to be a diene. These are 2 possible ways to name this compound. 5-methyl 4-vinyl 1,4-hexadiene, or 5-methyl 4-vinyl hexa 1,4-diene. In this case, this works if there are fewer functional groups in the molecule. As we start learning more functional groups, we will switch to hexa 1,4-diene to avoid any ambiguity. For this compound, we didn't have to worry about EZ nomenclature, and that's because we didn't have any possibilities for cis and trans. At this carbon, both the groups attached are hydrogens. Same here for this carbon. And on this carbon, you have 2 similar groups. You've got 2 methyl groups. In this case, there's no possibility of cis and trans isomers. However, when we come here, you can see that there are 4 different groups attached to each of these carbons. So this carbon has a smaller group and a larger group. This one has a smaller group and a larger group. In this case, we have to assign an E and Z nomenclature. Let's first start by just naming this compound. Look for the longest continuous carbon chain containing the alkene, and that's going to be this chain here. You want to give the lowest possible number to the alkene. So you're going to start with 1, 2, 3, 4, 5, 6, and 7. This is a heptene, and you have a 3-methyl group. So the name of this compound is 3-methyl 3-heptene. Just like for R and S, you need to indicate whether it's E or Z in parentheses at the front of the name. If you have more than one alkene, you would include it in the front of the name and precede it with the position number. In this case, we have one alkene, so let's assign E and Z nomenclature. We're looking to assign priority to each group on each carbon. So if we consider carbon number 3, the higher priority group is going to be this ethyl group. So this is the higher priority group. If we look at carbon number 4, we've got a hydrogen and a propyl group. The propyl group is going to be the higher priority group. The highest priority groups on both carbons are on the same side. So these are on the same side, which means that it is the Z isomer. So we can put in Z, and that gives our complete name. For cycloalkenes, you will use the cyclo prefix. You want to number the ring so that the double bond is at position 1. You do have to include both carbons of the double bond. So if you start here, you would say 1, 2, 3, 4. You cannot start here and then go 1, 2, 3, 4. You have to include both the double bond carbons. And make sure that all the other substituents get the lowest number possible. We have one substituent, that's the tert-butyl group. And if we were to number the carbons, we can start from here. 1, 2, 3, 4, 5, and 6. The alternative is to start from here and go 1, 2, 3, 4, and then in that case, this would get 5. So we want the lowest possible number, so the numbering in red is going to work. And when we name it, we're going to start with the tert-butyl group. So for tert-butyl, remember that the tert is italicized, and then the double bond is at position 1, and we'll include cyclohex and ene to indicate that there is an alkene. Alkenes can be differently substituted. You can have a monosubstituted alkene, so you have only one substituent and all the other substituents are hydrogens. You can have a disubstituted alkene. In that case, you can have the cis isomer and the trans isomer. And in a cis isomer, both the substituents are on the same side. In a trans isomer, both the substituents are on opposite sides. You can have a tri-substituted compound and also a fully substituted or tetrasubstituted alkene. You can see from the heat of formation of each of these alkenes that the alkene stability increases as the substitution increases. And so a monosubstituted alkene is less stable than a cis disubstituted alkene, which is less stable than a trans disubstituted alkene, and that's because for a cis alkene, you've got steric hindrance between these two groups here. A trans disubstituted alkene will be less stable than a tri-substituted alkene, which is less stable than a tetrasubstituted alkene. And in this case, we are comparing isomers of the same compound. For practice, try naming all of these compounds in the IUPAC nomenclature system. From the previous table, we saw that alkene stability increases as alkene substitution increases, and using that knowledge, let's rank the stability of the following alkenes. This is 1-butene, and these are the two isomers of 2-butene, where this one is cis and this is trans. The least stable is going to be the monosubstituted alkene. So this is going to be the least stable. Of the disubstituted alkenes, the trans alkene is going to be more stable. So if we were to rank stability, this is the most stable, this is the second most stable, and this is the least stable.